Okay, Aubrey, we're going to cover geometry lesson 7, 8, and 9 today. We're going to talk about all the different formulas for finding area of different polygons, finding surface area of a rectangular prism, and finding volume of a rectangular prism. So first is area. We know that area is, or used with capital A in a formula. An area of a polygon is the number of square units inside it. Formulas for finding area, coming polygons are below, and I'm going to go over that with you in just a second. But before we do that, go ahead and take a look at some of the things that we need to know. The first thing that we already know is length, right? And a lot of times it's written with this cursive L, and width. So for example, for this rectangle, I can use length and width to find the area because I know in a rectangle, it has 4 right angles. So that means the length and the width are automatically perpendicular to each other, okay? So area of a rectangle is length times width. And then we also use this S for the side length. So in a square, I can use length and width, but because I know that a square has 4 equal sides, I know that the length and the width will be the same. So I can just square one of the sides, or I can do side times side, right? Like if this side were equal 4, I know this side will equal 4 too, so I can do 4 times 4 or 4 squared. And then base and height. So if you look at this parallelogram here, now we're saying that this is the base and this is the height. And it's very similar to this length times this width. However, in a parallelogram does not have 4 right angles, does it? So what you have to do is you have to label one of the sides. It doesn't really matter which side you label. Now it's easier just to do the bottom one because you can easily draw a perpendicular line to the bottom one or the bottom length, and we call now that the base. It's kind of where you're starting from. And then you have to draw a perpendicular line to find the height of the shape. So the formula for finding area of a parallelogram is base times height. Now triangles are very similar to rectangles and parallelograms, but you're just cutting it in half. So the formula is going to be 1/2 base times height, and I'm going to show you why. So for example, I'm going to use a rectangle to do this. So if I have this rectangle, and I know the length equals 3 feet, and I know the width equals 2 feet, I know that the area is 6 feet squared. Now I can easily do that because I know that this is perpendicular here. And if I cut that in half to make a triangle, I still have the same length going across and the same width going right here, or the same base and the same height. So basically then what I can do is area equals 1/2 3 times 2. So area equals 1/2 of 6. And that's basically just 6 divided by 2, which equals 3 feet squared. And then it works with the parallelogram too. So if I know that my base equals 3 and my height equals 2, let's say feet again. Okay, so if I go ahead and I do that work there, I know the area of this parallelogram is 6 feet squared. But then if I cut it in half, let me see how I can cut it in half in order to get this, right here. If I cut it in half, right, this is still the same base and this is still the same height, or this is the same base and this is the same height. So it's just that base times height times 1/2. Another way, or 1/2 times base times height. Another way you can write it is base times height over 2, because you're just dividing it by 2. Trapezoid is one of my favorites. It's really interesting. And it sometimes can be a little confusing the way that the formula is written. 1/2 times the sum of base 1 plus base 2 times height. Now basically what you're doing by adding base 1 and base 2, if I say this is base 1 and this is base 2, by adding those two and then multiplying by 1/2, you're finding the average of those two. So, and then you're going to multiply by the height. And I'm going to show you how that works. So if I have this trapezoid and I label this as base 1 and this is base 2, and then I say this is 6 and this is 4. And then my height, which doesn't really matter, is, let's say 2. And let's say call these inches. Okay, So this base down here is 6, this base up here is 4. Now, if I were to turn this into, if I were to take these end pieces off and turn this into a rectangle, which actually it kind of turns into a square, I know that this is 4, which would make this also 4, right? And then I would cut off these two pieces, and what's 6 minus 4? It equals 2. So each one of these pieces together would be 2, which means each one of them 1. Okay, so then if I take this triangle off and I put it over here, now I have 1 over here and 1 over here. So this total length is 5, and this total length is also 5. So now I have this pretty rectangle here that I can go ahead and just do 5 times the height, which is 10 inches squared. So the way that would then work here is area equals 1/2 times the sum of 6 and 4, base 1 and base 2, times 2. So then area equals 1/2 of 10 times 2. Area equals, what's 1/2 of 10? 5 times 2. Area equals 10 inches squared. So I really like that one, and it seems a little confusing here, but as long as you understand that you're just taking the average of the two bases and then multiplying it by the height, it's really simple. Another way that is written too is base 1 plus base 2 times height. Well, actually it would be, and it doesn't, and you can use the associative property because it's all multiplication. Like I could have multiplied 2 times 10 and then multiplied it by 1/2. 2 times 10 is 20. Multiplied by 1/2 is 10. I could have done 2 times 1/2 times 6 plus 4. 2 times 1/2 is 1. Times 6 plus 4 is 10. So because of the associative property, you can switch those numbers around and still get the same answer. So a lot of times you might also see this. So the sum of B1 plus B2, or the sum of B1 and B2 divided by 2 times height. Sometimes it's written like that. All right, let's see what the work is here for us. What is the area of the shaded region of this figure? The shaded area is a trapezoid with H that equals 10 meters and B2 equals 6 meters. So what's kind of cool here is we have, what are we trying to do? The trapezoid. So this is the trapezoid we're doing, right? The shaded area, okay? So now I know that this base right here, or these are my two bases, okay? So those are, the bases are the ones that have to be parallel to each other. So these are my two bases here. If I know that this is 6 right here, and this is 3, then what is this? Because this rectangle is, this is a rectangle, I know that this is 3. So I'm just gonna draw that going this way. So this is 3, and this is 6. And then my height here is 10. So then I can plug those numbers in. 1/2 times the sum of base 1 and base 2 times the height. So I plug those numbers in. 1/2 times the sum of 6 and 3 times 10. So 1/2 times 9 times 10. So 1/2 times 9 is 4.5 times 10 is 45. Or you could do 9 times 10 is 90 times 1/2 is 45. All right, can you use the formula area equals length times width to find the area of a square? Yes, because a square has a length and a width. It's the same thing. So it's basically what we just said about here. This can be the length and this can be the width. It's the same thing as just doing side times side. All right, what is the area of the figure to the right? So here's this figure, and so it looks like we're gonna need to split it into pieces because it is a non-regular polygon. So I'm gonna cut it right here and make it into a rectangle and a triangle. So the larger figure can be divided into a rectangle and a right triangle. Find the unknown base and height of the triangle. To find the height of the triangle, subtract the known vertical lengths. So basically what's that saying is here's the height of, oops, you can't see that. Here's the height of this triangle, and then here is the piece that's left over. So if I cut this off a little bit right here, the height of this would be 10 minus 6, which equals 4. So 10 minus 6 equals 4, which is the height. Find the base length, subtract the known horizontal lengths. So if I know this whole thing right here is 7, but because this is a rectangle, it cuts off right here. So I know that this is 4, which makes this part over here 3. 7 minus 4 equals 3. Find the area of each polygon. Area of a rectangle is length times width, so 10 times 4 equals 40 inches squared. So this rectangle is 40 inches squared. Now I gotta find the triangle. 1/2 times base times height, so 1/2 times the base is 3 and the height is 4. So that equals 1/2 of 12, 6 inches. 6 inches squared. So 40 plus 6 is 46 inches squared. All right, let's keep going. A quadrilateral is a polygon with 4 sides. What are some common quadrilaterals you should know? Oh my gosh, you should know all of them. So obviously the most common quadrilateral is a quadrilateral, any shape with 4 sides. And then we start to break it down by like parallel sides and equal sides and right angles. So we also have a parallelogram, and a parallelogram has 2 pairs of parallel sides, which then also obviously makes them equal, 2 pairs of equal sides. A rectangle is a parallelogram, but it just has 4 right angles. So it has 2 pairs of parallel sides and 4 right angles. And then we get even more specific and we get to a square, which is a rectangle and a parallelogram because it has 2 pairs of parallel sides. It also has 2 pairs of equal sides. But when you really think about it, because all 4 sides are the same, you can also say that there's 2 pairs of equal sides. And then we have a rhombus. A rhombus is similar to a parallelogram and a square. It's like if a parallelogram and a square had a baby. You would get a rhombus because it has 2 pairs of parallel sides, but it has 4 equal sides. It just doesn't have 4 right angles. Then in kind of another family, you have a kite, and a kite has 2 pairs of adjacent equal sides or equal adjacent sides. So for example, a kite looks like this. Sometimes people call it a diamond. So that means that this side and this side is equal, and this side and this side is equal. So those are called adjacent sides. So it has 2 pairs of equal adjacent sides. And then you have trapezoids. And there's two different types of trapezoids. One is just a regular trapezoid. It might look, well, actually you have 3 types of trapezoids when you think about it. So you might just have a trapezoid that looks like this. Maybe even make it a little bit more odd looking. So there's a trapezoid. That's just like a common trapezoid. You have a trapezoid that looks like this. And that would be called a right angle trapezoid. And then you have probably what you've seen the most, a trapezoid that looks like this. So this side and this side is equal. And that would be called an isosceles trapezoid. What steps do you take to find the area of a composite figure? And a composite figure is what we just did, where we broke it up into 2 pieces. So this would be considered a composite figure. So what did we do to find the area? We broke it into smaller common polygons. All right, find the area. So this is a square, so your formula is going to be s squared. This is a triangle, so your formula is going to be area times 1/2 times base times height. Here's the base, here's the height. Parallelogram, area equals base times height, base and height. And then trapezoid, area equals 1/2 of the sum of B1 and B2 times the height. There's B1, there's B2, and they're interchangeable, and then there's the height. So go ahead and practice using these formulas. And let's see if you got to do any composite figures. Yes, this is going to be great. So you've got to do a couple composite figures here. Number 8 says the diagram at the right shows a hallway. What is the area of the hallway? So for these, I'm going to go ahead and just cut them for you. And so for this one, you can either cut it right here or cut it right there. Now, if you cut it, I don't think it really matters. I would actually, yeah, it doesn't really matter which way you cut it, because if you cut it here, now the whole length of this side is 6, so you would need to find what this would be, right? And since this is 2 and this is 6, you know it's 6 minus 2, that would be 4. And because you know that this is 5 and this is 2, the whole length of this would be 7. So you can find the area of this part doing 7 times 2 and the area of this part doing 4 times 2. This one right here, you could cut, I would cut it like this. So now you have a square and a triangle. And you know that here's the height right here because that's a 90-degree angle right there. So a right triangle is really easy to work with because you already have the height because it's a 90-degree angle right here in the corner. So this is the height and this is the base. You would ignore the hypotenuse of that. And so you would find the area of this by doing 1/2 60 times 80 plus 100 times 100. Ooh, this one's fun. So break this one up. Ooh, it's not as hard as I thought. You got a square here and a parallelogram there. And then this one right here, I would break it up going this way. Now you might think that would be easier, and you can certainly do that. But I actually think this one's easier because you know that this is 10, this is 16, you can easily find that. Because that's 10, you know that this is also 10 because the whole length is 20, so it'd just be 10 times 22. All right, and then you've got this last one. Meryl cut out a paper triangle. She then cut out a square out of its center. What is the area of the paper figure after she cut the square out of it? So I would find the area of the triangle, find the area of the square, and then subtract the area of the square from the triangle. And if you look carefully, the height of that, they're telling you the height is 3, so you can do the area of the triangle, 1/2 times base times height, and then you know that the length of this square, or the side, one side equals 2, so you can easily find the area of that square also. Good stuff in algebra. All right, surface area. Surface area is another formula that you need to know. And there's this kind of cool presentation I do with surface area. So basically I take this rectangular box that I've got and we figure out the formula for finding surface area by doing it. So I'm just going to show you, this is the net of a rectangular prism. Actually, it would have one more of these, right? So if I were to like fold this all up, I would have like a rectangular box or a rectangular prism for a box. So you can focus on this. This would be, like, you think about it, even if I did it maybe this way. So you would think about this being the length, this being the width, and then this part right here, this part right here is the height because it's how tall the box is. So to find the area of this, so let's call this number 1, you would do length times width to find the area, because we're doing surface area, right? So we need to find the area of all of them. So this is 1, let's say this is 2. So to find the area of 1 and 2, you do 1 and 2, length times width, right? And let's call this 3, and this is 4. So to find the area of 3 and 4, well, this is the width and the height. So it's width times height, right? And then let's say that this is 5 and 6. And so I have the length and the height. So 5 and 6 would be length times height, or length times height. And so then, I don't know why I keep doing that. So there are 2 of them, right? There's 2 of each one of those shapes. So the surface area equals each one of these times 2 all added together. So you have 2 times the length times the width plus 2 times the width times the height plus 2 times the length times the height. And then you could figure those all out, or figure all of those out and then add them together. Another way of doing that is you can, which I don't like to teach it this way because I like to follow formulas to the exact T, but another way my students have figured this out is you can figure all of these out, add them up, and then multiply it by 2. So another way of saying this is 2 times the length times the width plus width times height plus length times height. So you could figure all of these out, add them together, then multiply by 2, and you're gonna get the same thing. All right, let's see what they are telling us we need to do. The surface area of a 3-dimensional figure is the sum of the areas of all its surfaces. You can find the total surface area of a prism by finding the areas of each of its faces, then adding them to find the total. Surface area is measured in square units. Because it is the area, it's still just square units. So here's the formula for a rectangular prism, and then a cube is just 6 times the side squared. And the reason why that works is basically each one of these is the same. So you're just finding the one side, or one area of one of the squares. So it would be side times side, so side squared, and then you have 6 faces. So you're just multiplying that by 6. All right, let's take a look at this one. This is a cube. So we have surface area, and that's how I write surface area, is capital S, capital A. And I'm gonna find the area of one of these. So it's 6 times 5 squared. So surface area equals 6 times 25. Surface area equals 150 centimeters squared. It's right there. How is the formula for finding the surface area of a cube related to the formula for finding surface area of a square? Finding the area of a square. So area of a square equals side squared. Surface area of a squared is 6 times the area of one side. So it's side squared times 6. Sandra will paint this storage chest. Excuse me. She will not paint the bottom surface. Ooh, so you get to subtract one of them, or leave one out. But she will paint the top surface and all 4 sides. How many square inches of the chest will be painted? So we find the area of the front and the back faces. The front and the back faces are rectangles that are 30 inches long and 24 inches wide. So we're talking about this one and then the one that's directly behind it. The area of the front face is length times width. So we're saying length times width. So we're finding the area of this. That's 30 times 24, which is 270. Find the area of the left and the right side. So we're doing this one and then the one that's back there. And that is 20 inches long and 24 inches wide. And so that's 480 inches squared. Find the top surface. The top surface of the rectangle is 30 inches wide or long and 20 inches wide. So that's 600 inches squared. Find the surface area to be painted. So they have them adding them all up. So we're doing 2 of these, 2 of these, and 1 of these, right? So the front and the back, the 2 sides, the top, but not the bottom. So you're having 720 plus 720 plus 480 plus 480 plus 600. Yikes, that's a lot to add up. So let's do it. I would much rather multiply these or use a calculator, but I don't have my calculator handy. All right, 0, 8, 16, 20, 10, 14, 18, 10, 14, plus 28, 30. Is that right? So 3,000 square inches of the chest will be painted. So another way I might do this is surface area equals 2 times the length times the width plus 2 times the width and the height, width and height, plus just 1 length times width. No, length. Okay, length times width. Oh, no, we wouldn't do 2 times the length times the width. Length times width. No, that's right. Length times width, and then width times height, and then this is length times, this is the height, sorry. So 2 times the length times the height, so that would be this one, right? And then 2 times length times width times height, so that's these two, right? And then this top piece is length times width. So just one of them, length times width. So then surface area would equal 2 times 30 times 24 plus 2 times 20 times 24 plus 30 times 20. So I would almost just fill it out like that, and then solve from going there, from there. What is the total surface area? It is finding the area of all, or finding the sum of the area of all faces. What steps do you take to find the partial surface area? So that's kind of what we just did. I mean, you could find the total surface area and then like subtract whatever the surface area is from, or you can just use the formula and keep out whatever part you don't need. All right, so surface areas of these three using that formula. Now don't forget to figure out which one is your length, your width, and your height. So like I would say this is my length, this is my height, this is my width. And then just plug those numbers into the formula. For this one again, length, width, height, length, height, width, length, width, heights. And it doesn't really matter. You can flip all those three around. Because of the associative property and the commutative property, it doesn't matter which one is which, just as long as each one of these is different. And this one's a square, so it's side, side, side. But for each one of these, like this could have been the length, this could have been the width, this could have been the height. Like it doesn't matter because of the associative property. So go ahead and do all of these. And then take a look at some of your word problems. Jamie cut his net for a cube out of paper. So remember, the net is a three-dimensional shape turned into a two-dimensional shape. So like cut apart and flattened out, this would be called the net. She will then fold it into a cube. What will be the total surface area of her cube? So that's pretty simple because one area of one square is 6 times 6. So you're just gonna take 6 squared and multiply it by however many faces is in a cube. This next one, Leah bought 2 identical cube-shaped file cabinets, each with 12-inch edges. Then she placed them on top of each other, the bases touching, to make one large file cabinet. What is the surface area of the large file cabinet? So basically, you're finding, I would just find, can you find the area of this? Yeah, just find the area of this, right? Including the top and the bottom surfaces. So I would just say, instead of your height being 12 and 12, you could just say your height is 24 inches, your length is 12 inches, and your width is 12 inches. Another way you could do that is find the surface area of this one, which is the same as that one, and then you're taking away a top and a bottom, because those pieces that are like touching right here aren't a part of the surface anymore. So you wouldn't need to count them. Even though they're asking for the bottom surface, that one I know isn't like touching any surface. Well, I guess it's touching the ground, which is surface, but it's not exposed to anything. They still want you to count that. But I think the easiest way of doing that is just having the height be 24 inches. This next one, which has a greater total surface area, a cube with 1 inch sides or a rectangular prism with the dimension 2 inches by 1/2 inch by 1 inch. How much greater? So find the surface area of this and the surface area of that and find the difference. Hector will paint the walls of his bedroom. He will not paint the floor or the ceiling. Some people paint their ceilings the same color. So basically you're not doing this length times width. You're keeping that out. You're just gonna do length. This is the length, and this is the height, and this is the width, right? So you're gonna do length times height, and he has 2 of those, plus the height and the width. So the height and the width, so this side and this side. So 2 times the height and the width will be the surface area of all the 4 walls, right? Okay, next is volume. I love volume. It's just such a simple equation. So rectangular volume, to find this, now remember, volume is the number of cubes that can fit inside of a 3-dimensional shape. So we use cubic units to do this. So it would be like units cubed. And we use a 3 to show it is 3-dimensional, the length, the width, and the height. So to find the volume of rectangle prism, it is length times width times height. So basically what you're doing, another way of saying that is base times height. So basically what you're doing is you're trying to find like the base of this shape, and then how many are you building on top of it. So if you find the area of the bottom shape and then you just multiply it by the height, then you get the volume. And side is pretty simple, or when you have a cube, it's pretty simple because it's just the side cubed. You're basically finding the area of this and then multiplying it by the same length. So what is the volume of this rectangular prism? If I say that this is my length, this is my width, and this is my height. Now it does not matter. Oh, see, like they didn't even do that. Because of the associative property, it doesn't matter. Just as long as you give each one of those sides or each one of those lengths one of these labels. So they're saying 7 for length, 14 for width, and 3 for height. So 7 times 14 times 3 is 294 inches cubed. Let's take a look at this one. What is the volume of a cube with 2-foot sides? So you substitute the 2 for the S in this formula. So volume equals side cubed. So 2 cubed is 2 times 2 times 2, which equals 8 feet cubed. How is the surface area and volume different? So surface area is just the area of the outside. And volume is what fits inside. So that's just, the difference between area and volume. Area is just like flat, 2-dimensional, and volume is 3-dimensional cube. So you use square units here and cubic units for this one. All right, on the move, moving company sells 2 boxes that are shown, box A and box B. What is the volume of box A? What value should you substitute? Substitute 3 for the length, let's say 1 for the width and 2 for the height. Substitute and multiply, so 3 times 1 times 2 equals 6 feet cubed. So box A is 6. Box B is the same volume as box A. It is, but the dimensions are different. What is the height of box B? Ooh, this is the kind of stuff I love to do. However, I kind of already know the answer. Because I need to have this to be 6, 2, 4, wait, hold on. Yeah. Let's check it out. The value should substitute volume, length, width. So substitute blank for volume. We know what 6 is volume, 2 for length, 2 for width. So 6 equals, yeah, got it. Oh, I did not expect that. So then we divide this by 4, divide this by 4, and you get 2 1/2. So the height of box B is 2 1/2 feet. So I do like these kinds of problems though, where you, like if you get the volume but you don't know one of the dimensions, you have to figure out by plugging in what you do know and then doing algebra to figure it out. What is volume? The space inside a 3-dimensional shape. Now we're using cubes and rectangular prisms here, but you can find volume of any 3-dimensional shape. There are several different formulas for finding like volume of a cylinder, volume of a, volume of a cone, or volume of a pyramid. There's all different types of formulas. Right now we're just focusing on these rectangular prisms. A cube is a type of rectangular prism. Could you use the formula for finding volume of rectangular prism to find volume of a cube? Yes. This is kind of the same thing as the area question. Yes, because the length and the width and the height can be the same, which would then just be side times side times side. All right, so you're gonna use those formulas to find this. And you got some word problems to do. And this should be pretty simple as long as you know that volume and you use your algebra. If there's a missing dimension and if you know the volume, but you don't know one of the dimensions, you may have to use algebra to figure it out. But I think you got this. You can email me or Google chat me if you've got any questions. Enjoy.